Alright, sorry, long story short, let me start over on number 5. I totally missed all that. Woo. Let me get my life together. Okay, number 5. You just saw, so let me restart that. Already saw part of it. Here we go, 5. Number 5 was oh yeah, this is the one that I was going to start and I didn't get to in class the other day. So this one, they give you a function. In this case, it's 5x minus 1 over x plus 4, and the directions ask to describe how it can be obtained by transforming the graph. So in other words, I just need to know how far it moves left and right and up and down. So I already know that it moves to the left 4 because of this plus 4 thing right here, right? We know that, but I don't know how far is it dilated? Does it move up and down? And so I have to do something with that 5x plus 1 on the top. So if you recall, what we did is we long divided. So I need to know how many times x plus 4 will go into 5x minus 1. Now, I just need to know what would I multiply this times to make it this. Of course, I just need a 5, right? So the 5 would go here, 5, and then you distribute. 5 times x is 5x, and 5 times plus 4 would be plus 20. Now, if you recall from old school, like long division, I need to subtract. But not only do I need to subtract this first term, I have to make sure to subtract both terms. It's like distributing a -1. So what we end up with, of course, is obviously these two are 0, right? That's what we wanted to happen, and this is -21. And that is my remainder. So how to write this properly with a remainder? Remember, it is 5 over, oops, not 5 over. My brain's getting ahead of itself. F of x equals 5, because it goes into it 5 times, and then minus 21 over x plus 4, right? Your remainder goes on top of what you're dividing by. Now, of course, we actually saw it more of along the lines of -21 over x plus 4, and then if that 5 is positive, so plus 5, right? That minus goes with the 21 because it's in front of it. Because whenever we talked about transformations, it looked more like that second one, looked more like this one right here. Okay, so now that I've divided, I can look at it and go, okay, this graph has been reflected, right? That negative being multiplied on the top means that it has been reflected. It's being dilated by a factor of 21. Factor of 21. And again, that's because the parent function, just as a side note, like the default function, so to speak, is just 1 over x, right? So normally it's just a 1 on the top. So if I multiply that 1 times 21, obviously it's going to be dilated in some manner. And then because of, as we said a minute ago, because of the plus 4 on the bottom, we know it's going to move left 4. And then now we can see that we are adding 5 to the whole function, right? My reciprocal function plus 5, it's going to move up 5. So that's what I'm looking for. I'm looking for how has it changed. So the negative reflected it, the multiplying it times 21 dilated it, and then it moved to left 4 and up 5. That's number 5. Fun times. Number 6. Number 6. What is number 6? Oh, we have to evaluate a limit based on the graph. Oh, that means I need a graph. Okay, so the graph will be given to you. Did I scan this thing? I didn't scan it. I just started writing. Listen, y'all, I started this on Friday and it's Sunday, so I don't remember what I did yesterday most days. Okay. So this graph is just a basic reciprocal function, and it looks like the asymptote is at -4. So I'm going to do it with a green pen so it's kind of obvious. All right, so -4, and then I'll hide, there's an asymptote right here. Now on your test, the asymptote's not drawn, but you can look at it like it's on a nice, pretty actual graph. And then, and we all know I can't draw, but it's one of those reciprocal functions that like goes like this. And then on this side, it goes like this. That is actually not half bad for me. Okay, so it says, hey, here's this function, evaluate this limit. So in this particular case, you're asked to evaluate the limit as x approaches -4 and from the left. So all of this is the question. They'll give you the graph and where they want you to find the limit from. Again, this is where we're going to, and this is going to tell us if it's left or right. Kind of like back on number, whatever it was. 4? Oh, yeah. Yeah. See the minus and plus on the left and right side of those 4s on number 4? All right, so that's, so here, since there's a minus sign right here, we know that means on the left side. So if you look on the left side, as it approaches -4, it's going down. So as it approaches -4 from the left, it equals -infinity. And that's it. That's your whole answer. Number 7. Number 7. So for the given function, we have to find the horizontal asymptotes. Okay, so this is the one where I hope that you wrote down your notes. There were 3 scenarios of not horizontal. Yeah, horizontal asymptotes, guys. Again, it's Sunday, and it's like 7 o'clock at night. I don't know. X squared plus 9x plus 5. Okay, yes, so it's asking, hey, what are the horizontal asymptotes? Okay, so 7, and I believe 8 also. Yeah, 7 and 8 both ask for the horizontal asymptotes. Okay, so again, this is where hopefully you have your rules written down, because there were 3 different ones, right? Either it's 0, there isn't one, or it's a number based on what the coefficients are. So here, we can see that this is a degree 1, really, right? But we don't write it. So this particular problem, the degree of the numerator is less than the degree of the denominator. Again, we don't care what comes after these x's. It is not important when we're trying to find the horizontal asymptote. So since the degree on the top is smaller than the degree on the bottom, this one's horizontal asymptote is y equals 0. Like, that's it. You don't have to figure out anything special. Like, that is the horizontal asymptote for number 7, because the degree of the top is smaller than the degree of the bottom. Whereas on number 8, same question, different function. 7x to the second plus 3 over something. 7x to the second minus 3. Oh, that was scarily close. Okay, so again, it says, hey, let's find these horizontal asymptotes. So if you look now, oops, sorry about that. You can see that the degrees are the same thing, right? This is a degree 2, this is a degree 2. So if the degrees are the same, then the horizontal asymptote comes from the leading coefficients of the numerator and denominator. Of course, that happens to be a 7 over a 7. So the horizontal asymptote for number 8 would be 7 over 7, which of course we know is actually 1. So the horizontal asymptote for number 8 is 1. So please go back and make sure your notes, like you have that list from our notes, because we all know my computer is on let's do a new number. Again, the other option was that there's not one, so go back and look at that one. And then 9 and 10 are the solving ones. These are the fun ones, of course. So let's do those. 9 and 10 are here. Let's solve it. Number 9 is, in my opinion, the easy one. X minus 5 over 8. And that equals 4. Okay. So if you gave me this problem and said, hey, find a solution, I'm going to get rid of those fractions. as much as I love fractions. But it'll just make it easier to do, right? And I know that the common denominator here would be 8. Please remember this 4 is over 1. Which means I'm going to multiply literally everything in this equation by 8. So like I'm multiplying by 8 because 8 is the greatest common factor of the denominators. It's the common denominator. What that means is I'm going to do 8 over 1 times x plus 3 over 4. 8 over 1 times x minus 5 over 8. And then 4 times 8. All right, 4 times 8. That looks weird. I'm going to make that a big 4 and 8. That just looks weird. 4 times 8. There we go. Okay, on the left side. So obviously 4 goes into 8 2 times. So really, I'm just doing, on this first one, I'm just doing 2 times x plus 3, right? It's the distributive property. So I'm going to go ahead and do that. So 2 times x is 2x. 2 times plus 3 is 6. Then, on the next one, 8 and 8 divide out, right? So that's great. Now do be careful because this is a minus sign. So that's almost like distributing a negative number. So that would be negative x, but then it would end up being a plus 5 because a negative times a negative is a positive. So be careful with that. It's like it's the same thing as saying, hey, I have a negative 1 times x minus 5. Right, that's really what that's like. And of course, 4 times 8 is 32, and we end up with a very easy equation that I'm going to go ahead and solve. Wow, this is extra easy because look what happens. Like my coefficient of x is just 1. It's like super easy. X, and then of course 6 plus 5 is 11, which is equal to 32. And then subtract 11 from both sides. So my solution to number 9 is, what, 21? Sure. If I screw up on my adding, y'all know that I can't add. Yes, 21. Okay, so that's number 9. That's the easy one because you don't have x's in the denominator. That's pretty okay. So let's look at the one that does have x in the denominator. It's very similar to several of the ones that we practiced. This is an actual rational function equation. 4 over x plus 9 plus 9 over x plus 8. And that equals 7 over x squared plus 17y plus 72. Okay, now, as I told you, since we are in the learning pre-calculus stages, I'm not going to use anything crazy. This is similar to the one we did in class in that I know if I were to factor this one over here on the right, this would be x plus 9 times x plus 8. Because 9 times 8 is 72 and 9 plus 8 is 17. And they're nice to do that because that means that's going to be my common denominator. Now your two options are, of course, do it just like we did this last problem, right? We can do it just like we did this top problem and multiply everything times x plus 9 times x plus 8. Or we can find the common denominator and add the 2 on the left and cross multiply. I don't care. I think, if I remember correctly, several of you guys asked me to do the multiply everything times, so I'm going to do it that way. And if you want to see it the other way, then I can do that really quickly the next time I actually get to see your faces, whenever that happens to be. Just let me know. Okay, so I'm going to treat this one like I did the last one. I know that the common denominator is x plus 9 times x plus 8, right? So I'm going to multiply the whole thing times x plus 9 times x plus 8. And I'm writing it in factor form because I promise it will be nicer to do that. Okay, so what that means is I'm going to, oh, gosh darn it. This thing's so touchy. Here we go. All right, here we go. Ugh, I'm not going to say a bad word. I just need to stop touching it on that little arrow thing. Okay. Okay, now let's try that again. So x plus 9 times x plus 8, my common denominator, times 4 over x plus 9, right? Just like we did the last one. Plus, same thing with the second term, x plus 9 times x plus 8, sorry, my 9 looks like an A, times 9 over x plus 8. And then, of course, 7 over all of that stuff, x squared plus 17y plus 72 times, I'm going to run out of room, x plus 9 times x plus 8. Okay, just wrote it up there because I don't have any room. So I treated it just like the last problem. I know the common denominator is x plus 9 times x plus 8, so I'm multiplying every term times that thing, and here's what's going to happen. For my first term, the x plus 9's go away, right? So what I end up with is 4 times x plus 8. Plus, on the second term, the x plus 8's go away. So that leaves me with 9 times x plus 9. On the last one, this whole denominator goes away with my common denominator, right? They're the same thing. We just talked about that. If we were to factor x squared plus 17x plus 72 out, that's what it's going to get me. So it's just going to equal 7. So that means what I have to do. Oh, I gave y'all a nice one. Not like the one we did in class that had x's in the numerator. I just noticed that. So use the distributive property and solve it, right? You get 4x plus 32 plus 9x plus 81. Right, I use the distributive property here and here. And it equals 7. And then the rest of it is, can Miss Wyndham do her math right? 4 plus 9 is 13. Oh, Jesus. 32 and 81. Listen, I do not trust my brain today. 113? Sure. Equals 7. And then subtract 113. Does this not come out nice? Listen, y'all, don't trust my brain. 32 and 81. Okay, so I did subtract that right. So 7 minus that is definitely 106. Is that divisible by 13? Oh, it's definitely not divisible by 13. But 4 plus 9 is 13. Yeah, I did that right. Okay, so we just have a yucky number. Just double checking myself, because you never know with me, right? Anyway, you do get a negative 106. That's an equal sign. Equals negative 113. 106. I said it. I didn't write it. And then divide by 13. And that, 13. And that does not go in nice, like at all. It doesn't reduce. I mean, 13's prime. And it definitely doesn't go into 106. I got a real not nice number on my calculator, guys. I was just double checking my math. So that's my answer. X is equal to a negative 106 over 13. Now, normally we would have to check for extraneous solutions if we have an x in the denominator. But like the only two numbers that would give me 0 would be negative 9 and negative 8. And that is obviously neither one of those. So that is the solution to number 10. All right, there you go. There's your review. Have fun.